So we're going to look at assigning oxidation numbers to elements in a compound. First, the oxidation number is not equal to charge, although it can be. If you have a monatomic cation, then these are going to be the same number. But oxidation number is something different. You can find oxidation numbers for an atom in a molecule, like water. In water, you've got hydrogen and oxygen atoms, and neither of them has a charge. It's not an ionic compound. But they have oxidation numbers, oxidation states. So we can find this for everything. You're going to go in a certain order. Some elements are kind of more prone to finding or to having certain oxidation states, and so you make sure you pay attention to those elements first. They're going to do what they're going to do, and then the other elements that are with those elements have to kind of go along with it. So make sure, so you assign certain elements first, then as long as your sum of the oxidation numbers equals the total charge, you are correct. It could be zero. If you have molecules, your total, all of your oxidation states should add up to zero. If you have a polyatomic ion, then they should add up to whatever the charge on the polyatomic ion is. All right, let's look. This is the order that you assign the elements. Falco. If you remember Falco, fluorine first. Fluorine gets a -1 oxidation state. Then alkali and alkaline earth metals get an oxidation state, and this should be +1 and +2, just based on group. H is a third. That gets a +1. Oxygen then gets a -2, and then the rest. So Falco, that's the order. So let's do a few examples. We're going to assign oxidation states. We're looking for numbers that are for a single atom. So even though I see a 2 here, I'm going to write a number that's the oxidation state of a single hydrogen atom. And if we look in order, I would assign hydrogen first. Hydrogen gets a +1. Okay, so +1, but +1 times 2 means we've got a +2 there so far, and we need this to add up to 0. We have 2 oxygen atoms. So the oxidation state of oxygen in this must be -1. Right? This has to add up to 0 because this doesn't have a charge. So the oxygen, even though there's a rule that says oxygen gets a -2, that is typical. But hydrogen gets its oxidation state first. So even though oxygen's oxidation state is usually -2, in this case it's -1. That's it for that one. Let's go to number 2. We've got sulfuric acid. We'll go in order. So hydrogen comes first. We give it a +1. Oxygen comes next. We give it a -2. Now we've got +1 times 2 is +2. We've got -2 times 4 is -8. So -8 and +2, we're going to need another +6 to make 0. So sulfur's oxidation state in sulfuric acid is +6. Number 4, we've got Na and H. Sodium is an alkali metal, so that gets its +1 first. And so this is the only type of case where you're going to get hydrogen that doesn't have a positive oxidation number, because alkali went first. This has to add up to 0. So the only way for that to happen is if the oxidation state on hydrogen is -1. Number 4, we've got carbon, hydrogen, oxygen, and hydrogen. So we've got 6 hydrogens. That goes first. So we're looking at +1, and over here I'm going to write a +1. Oxygen comes next. It's -2. So we've got 6 hydrogen atoms at +1 each. That's +6. -2 for oxygen. But we need another -4. We've got 2 carbon atoms. So each carbon atom is going to be -2 in that case. Next one is C2F4. F is first on the list, so we make that -1. That's -1 times 4 is -4, so the carbon has to be +2. Okay, so these are not charges that we just wrote. These are oxidation numbers. So this is something you need to be able to do, but just really remember, these aren't ionic compounds. Well, maybe this is an ionic compound, sure, but these aren't ionic compounds, a little different.